Okay, I'm going to describe dense set. So we need to write down. I'm thinking about either writing it down or typing it. Give me 1 second. I'll just write it down actually. So what is a dense set? Dense set. What is it? A dense set. So we're going to put this definition into the context of, let's say we have a set X contained in the set of all real numbers. Okay? And there's going to be a subset of X. So we're going to take the subset. With this open containment. And this definition of dense set will apply to S. Okay, so we're going to focus on just S here. And that was related to real numbers. So really, you want to see this relationship if you're looking at the whole thing. Okay? And S is dense when, right? Because we know that there is a term called nowhere dense. I'll describe that a little bit later. But just knowing that there's nowhere dense sets, that means that this statement I wrote can't hold true without further description and qualification, right? So what is the criteria to call this particular S dense? Well, S is dense if, so I'm going to write the antecedent for any epsilon, so some epsilon, some arbitrary epsilon, and some little x contained in the set X we described. There's some hold on, let's make it more clear for y'all. There we go. So we have this x, this lowercase x contained in x. There's some s contained in s. The big S, right? The one we're trying to prove is, which is a subset by the way. We're trying to prove this one's dense. So we're keeping this in the back of our minds. Is this guy dense, right? Alright, so it's going to be such that X, which is contained in the big set, minus this S, the dense set, is going to be less than epsilon. Now, this notation may be arbitrary, but think convergence. And limits. Another thing you can think about is the monotone convergence theorem. where you're proving something is bounded, and there's monotonically increasing criteria as well. So these are some intuition as to why this notation is used. And we have epsilon greater than 0, so this positive value means that we're only interested in the positive value of x minus s. Because if we were to remove the absolute value, and this was a very big negative number, like if the magnitude of that number was very big, it wouldn't be detected by this test. So this is a very strict format. So basically, this is the definition of being dense. They're focused on the subsets element, lowercase s, contained in S. So we could even say S lowercase such that it's going to have this whole convergence thing. So you're thinking of a sequence, almost like a set containing values that can converge. So I would try to say an equivalent definition would be this big S. This big S here is dense in X, which is contained in R. If for any X we say there's a sequence contained in S where this whole thing happens. So you're basically saying that S is dense as long as it helps with the convergence process. Okay? So hopefully that helps you understand what a dense set is.